calculator today for sure, because we're going to be using it, and some of these questions have some weird answers. Okay, so just a single logarithm. By itself, there's no other information. What you want to do is isolate the logarithm. So this just says log of x minus 10 equals 8. And just remember, you cannot take the log of a negative number. So if our answer ends up causing that situation, we might have an extraneous solution or no solution at all. So first thing I'm going to do here, just there's no parentheses. It doesn't say like log x plus 10 in parentheses. So the plus 10 is to the side. So we're just going to move that. So this would just end up being log of x equals 2. Okay, does anybody remember what the subscript is if they don't have a subscript? 10. Okay, so this is called common logarithm. I will put this in the problem just to give myself something to move. But basically, what we're going to do here to get rid of the log is convert this to an exponential. So all you're going to do, you're going to swing the base of the log to the other side. That gets rid of the log. The x is going to stay where it's at. Base of the log becomes base of your exponent. So just think of that 10 pushing that 2 up in the air into being an exponent. And then maybe you know this, maybe you want to grab your calculator, but 10 squared is 100, and that's your answer. And that's all you have to do. So the next question right next to this. All right, log base, I've got the log isolated. I do have parentheses here. You cannot add or subtract stuff out of these parentheses. We're just going to directly get rid of the log here. This one has a base of 2. So you just take the x plus 4. You can go ahead and drop the parentheses when you move that. The base of the log is going to push that 6 up into the air to be base of an exponent. Grab your calculator if you want to. 2 to the 6th power should be 64. And then all you got to do there, we're just going to subtract the 4. And just make sure this should be fine. We're not going to take the log of a negative number if we plug in 60 to the original problem, so it should be okay. That's all you got to do. Okay. Now, on the last one here, there's a 4 out in front. You could put the power rule and put that as an exponent. I would not recommend that. I would actually just tell you, I'm just going to start out and divide both sides by 4 here. So I have the log base 8, 7 minus 2x, and then negative 12 divided by 4, negative 3. Okay, I'm going to swing that 8 to the other side. So I get 7 minus 2x. Now 8 to the negative 3. Remember, that's not a negative number. That would be a fraction, but you can just do this all right on your calculator. But 8 to the negative 3 power is really 1 over 8 to the 3rd. So it's just a tiny decimal. So I'm just going to grab my calculator, and I'm going to do 8 to the negative 3 power, which is a tiny decimal. It's 1 over 512. That's why it's so small. What I would do from there, we want to get the x alone. So I'm going to subtract 7. I'm just going to do it right on the screen of my calculator, minus 7. And then I have negative 2x equals what I've got on that screen. So just divide that by negative 2. The negative's going to cancel out, and then if it's not a nice number, these questions are going to ask you to go 3 decimal places. So this would be about 3.499. It's not going to, if I plug that back in, let me see, is that going to cause me to take the log of the negative? So if I do 7 minus 2 times that 3.499, it's not a negative number. It would be a really tiny decimal, but it's not a negative number, so that should work in the original problem. Does anybody have a question? Okay, now the rest of these are not quite as simple in terms of they just have a log by itself, so we want to try to get a single log, or we might have to manipulate in another way. So these are going to use the log properties. So you're going to have to remember what we were doing a couple lessons ago. So if I have adding between 2 logs with the same little subscript, what am I going to do to squish that together as a single log? Multiply. Okay, so these are both base 3, so log base 3. And skip this step if you want to just go ahead and multiply it. But I'm going to do 9 times the 5x, which would really result in, oh my gosh, don't write down what I just did. Okay. 45x equals 4. So then this turns into the problems we were just doing. Once you have a single log, we can get rid of the log by swinging that lovely base to the other side. We're going to make this exponential. So leave the 45x right where it's at. The base of the log pushes that 4 up in the air required to be in an exponent when we convert this to exponential form. And you might know that off the top of your head, you might not. But 3 to the 4th power is 81. And then all I have to do is divide by 45 real quick. So if I do 81 divided by 45, I got 1.8. So you could leave it as a fraction if you want to, or you can write it as a decimal, whatever is easier. That was a decent decimal, so I'll leave that. Now, the question right next to this, I'm going to attempt to do the same thing. I have here a number out in front of both of these terms, and that I can use the power rule with. That can become an exponent on whatever's following. So let me just apply that real quick. This would be log base 2 of x to the 4th. Okay, don't use a negative exponent. Go ahead and keep this as subtraction. This would be the log base 2 of 3 squared. Now, because and I'm just going to write this to the side. You guys would be okay with me saying 3 squared is 9, right? All right, now, in between these two, I'm subtracting. So subtraction, if we're squishing together as a single log, is going to convert that to be division. So I'm going to have x to the 4th, and then over 3 squared, which I'm just going to go ahead and write 9. Now, once you're there, we're just going to get rid of the log by converting this to an exponential. So swing the 2 to the other side of the lovely equation there. I'm going to get x to the 4th over 9 equals 2 to the 7th. The base of the log becomes the base of your exponent. We're pushing that 7 up in the air. This would be x to the 4th over 9 equals, that's 128 if you do 2 to the 7th power. Okay, now I'm going to do 128, multiply that by 9. I'm just going to do it on my calculator there. And then I'm going to get x to the 4th is 1,152. How do I get rid of a 4th power? 4th root or 1/4 power. Okay, it's up to you. It's less buttons. I use the 1/4 power. It's less buttons to push. I'll show you how to do both. Okay, so I usually do the reciprocal power, so the 1/4. Now, technically, if I'm doing a 4th root, we should put a plus and minus. I'm not going to here because I cannot take the log of a negative number. So if I get a negative, like a plus minus answer, it wouldn't work in the original problem because right there you just have log of x. So I don't want to put the plus and minus. So 2 ways to do this. If you want to do a 4th root, you can hit the math button, and it is the 5th button down. And you can type in a 4 and then type in that 1152. If you have an 83, you have to type the index you want first. So if you have an 83, you would have to type the number 4, then hit the math button, then go down to number 5, and then type in the 1152. Or if you're me, you're going to type 1152, hit the exponent, and do the 1/4 power because it's less buttons to push. I don't have to go into a different menu. They all give you the same answer. It's totally up to you. I usually use that reciprocal power to help me out because it's less work. All right, so this is 5.8, let's say 26, right? If I round that to the nearest thousandth, which most of these questions are going to have you do that. And again, I don't put a plus minus because if I had a negative answer there, it would cause me to take the log of a negative number, which I'm not allowed to do. Okay, and I have one more. We're just going to squish this together. Subtraction turns into division. So this would be 6 over 3x. And you can reduce that if you want, or you could just leave it alone. I'm going to swing this to the other side to get rid of the log. Base of your log becomes the base of your exponent. This would be 8 to the negative 2. And I'm just going to write that. That'd be 1 over 8 squared, so it'd be 1 over 64. And if you want to, we could just solve that like a proportion real quick. I'm going to cross multiply. So I'm going to do 6 times 64. We get 384. 3x times 1 would just be 3x. And then I'm going to divide by 3. This is actually a nice value. I got 128. There's my answer. And then just make sure it doesn't, if I plug that back in, it doesn't cause you to take the log of a negative number. You should be good. Is anybody having questions about the log properties at all? So subtraction turns into division, addition turns into multiplication, number in front. Okay. Now, the these are each just a little bit different things that you could run into. Okay, so I have log base 2, 8x plus 2 equals log base 2, 16x plus 4. How would I solve this one? I've got logs on both sides. We could do it like that, yeah, because we could swing it on both sides, or you could just, if you want, do you guys see how these are both base 2? That you're not dividing, but they literally just, like that, they cancel each other out. That's all you have to do there. You can just do, because if you do, Luke, if we did what you said, you would just set the exponents equal because they would have exactly the same base. So you're exactly right. But you could, if you want to just, if they're the same on both sides, just one log by itself, one log by itself, as long as they have the same subscript, that forces them to be equal to each other. Okay, so then I'm just going to solve this real quick. Now, subtract 8x here. So I'd get 2 equals 8x plus 4. I'm going to subtract 4. And so we're going to get negative 2 is equal to 8x, right? Divide both sides by 8. And I get negative 1/4. Now, I know this is super nitpicky. If you plug that back in, we're not allowed to take the log of a negative number. If you plug in 8 times negative 1/4, and you add 2 to that, it's actually 0. And I'm going to put this in here. You cannot take the log of 0. So this is super nitpicky, but this actually has no solution here. So if I just have the log of 0, I just gave that to you, and I'm just making that, we could use any base we want. There would be no exponent that I could plug in that situation that would make that true. You cannot take the log of a negative number, and it doesn't happen very often, but you actually can't take the log of 0. That would be like an asymptote on our graph. If we were looking at that, it doesn't ever actually equal 0, so this actually would be no solution for this question. If we got anything that was positive or some other number, as long as it didn't make our what we had in the parentheses equal to 0 or equal to a negative, we would be fine, but this is just kind of a nitpicky question. Okay, now the rest of these, a little tricky, but I know you'll be able to do them. So in letter E here, I've got logs on both sides. But then I also just have this, like it's just a 2. So I can't just have a log, in this case base 6, equal log base 6, because I've got this extra number here, this 2. If that's the case, what you want to do, let's try to get all the logs on one side so then we can actually use our properties to condense or to put as a single logarithm. So I'm going to take that entire term, the log base 6 of x plus 4, I'm just going to add it to the other side of the equation. Now, when you do that, we'll, on this left side, attempt to just put this together as a single log. So if I add that to the other side, that's going to create a situation. This will just be equal to 2. We're going to scrunch these together. And when I do that, if I have adding, that turns into multiplication. So I'm going to have to take x plus 4 times x minus 4. Which would just be like a little FOIL. It's not a big deal. I'm going to get rid of the log here, though, real quick by scooching that to the other side and converting this to an exponential. So I'd have x minus 4, x plus 4, and then that would be equal to 6 squared. Okay, so I'm just going to FOIL real quick. So we'd get x squared plus 4x, but then we'd turn around and get minus 4x, and then minus 16. 6 squared is equal to 36. Those two middle terms there are going to cancel each other out. So I'm going to get x squared minus 16 equals 36. We're just going to add the 16. This doesn't end up being a nice number here. Add the 16. You get x squared is equal to 52. Okay, then we're just going to take a square root. However, we are not going to put a plus and minus because If I get a negative answer, if I were to plug it back into the original problem where I have that x minus 4 in the log, it's going to take a negative number as a log, so don't put the plus and minus here. It should actually just be positive square root of 52. If you want to do that on your calculator real quick, it's about 7.211 to 3 decimal places. Just remember, you can't take the log of a negative number, you can't take the log of 0. Okay. Now, this one, I've got 3 different logs, 2 on one side, 2 on the other. What I would do here, I'm just going to scrunch these ones on the left into a single log. If you have subtraction, these are a common log. It's just plain log, so it's going to be base 10. We're going to put whatever comes first on the top, whatever comes second on the bottom, so the 2x minus 3. And then this is the log of 8. Now, this is kind of like the very first question we started the page with. If we just have a plain log on both sides, it's the same base, this would be base 10 in this scenario, then these just cancel each other out. So I have the log of something equals the log of something, same base, then they have to be equal to each other. So I would just do x plus 1, 2x minus 3, that has to be equal to 8. Just to make it a little easier to work with, I've got variables in the top and the bottom of that fraction which can't be canceled because you have adding and subtracting. I would just write like 8 over 1 and just do a proportion real quick. That's probably the fastest way to do that problem. So when you do your cross products, if you have a couple terms like I do here, you're just going to make sure you use a distributive property. Now x plus 1 times 1 is just x plus 1, so that's not going to change. But if I do 8 times this 2x minus 3, I'm going to get 16x minus 24. And then however you guys want to solve it. If it's me, I like to keep my variable positive if I can. So I'd probably subtract the x there. So I'd have 15x minus 24 equals 1. I'd add the 24. So I'd get 15x equals 25. So we're going to do 25 divided by 15. And should be 5/3, or if you want to write that as a decimal, it's 1.667 rounded to 3 decimal places. And as long as it doesn't cause you to take the log of a negative number, you're good, which it will not there. And then I have one more. Now, I've got 2 logs on the same side. I'm going to condense them into one, so addition is going to squish together and be multiplication. So we're going to take 3x minus 18 and multiply it by the x. Okay, I'm going to go ahead and get rid of the log by converting that to an exponential real quick. And so we got the 3x minus 18. We're going to multiply that by x equals 3 to the 4th power. All right, so I really have 3x squared minus 18x. If I distribute that distributive property, it's not a FOIL. And then 3 to the 4th is 81. So unfortunately this is going to result in a quadratic. But I promise if you get a quadratic it will be factorable, or you can use the quadratic formula. So first thing I would do here real quick is set this equal to 0 by subtracting 81 from both sides. Okay, now before I try to factor this or use the quadratic formula, what do you guys notice about all 3 of those terms? By 3. Okay, if you're working with an equation, you don't have to like pull this out in front or anything like that. I can literally just divide everything completely fine to divide 0 by a number that's going to be 0. So then I'm working with x squared minus 6x minus 27 equals 0. Again, if you want to use quadratic formula, you're welcome to do that, or I promise it will be factorable. Can you guys think of 2 numbers if you multiply? Go ahead. Negative 9 and positive 3. Now, my actual answers there would be positive 9 and negative 3. And just remember, you cannot take the log of a negative number. So, if you go back to the original problem, if I plug in negative 3 for either one of these logs in the original problem, that would cause me to take a log of a negative number. If you plug in 9 times 3 is 27 minus 18, that's good, that's positive. Just plain log of 9, that's fine. So the negative 3 there would be what we would call an extraneous solution. The 9 would actually be the only answer that would work. Sometimes on these questions you might have 2 answers. Sometimes you might have one. Sometimes it's possible that neither one of them would work. Okay, I went through